Hey, I'm Chili. Welcome back. We're on episode 3. And I'm fucking pissed because I had to stop my recording and start over. Fucking bullshit. Anyways, so last one we worked on, we just put the tip in on our, working on our map. We just the tip. But now we're going balls deep, son. So, let me explain all this shit again. Fuck. Alright, so what are we doing? So last time we set up the start position. And we got the responsibility for loading shit moved from the polyline into the map. So now what we want to do is we want to take it a step further. So we've got, let me just give you a little illustration here. We've got, so far, we've got loading an outside boundary. What we want to do is load an inside boundary as well. That's going to require a bunch of shit. At first you may think, that's pretty simple. Well, actually it isn't, fuckhead. I'm sorry about that. I didn't mean to call you a fuckhead. I was talking to myself, because I was thinking, this is going to be easy. Fuck no. This was a pain in the ass. Probably mostly my fault, but anyways. So, we want to load 2 polylines, well, at least 2. One for the outside boundary, one for the inside boundary. And that's going to require a little change to our infrastructure. Change number 1. Outside boundary needs its normal pointing in, but inside boundary needs its normal pointing out. So we need to modify polyline in order to enable both inside and outside facing polylines. How do we do that? Well, you could do it a number of ways. I'm going to show you the way I did it. First of all, let's load up our bullshit. So you want to make sure you're connecting to the HUGS project. And then you want to go to make sure you sync with the shit. Then you want to go to branches, and I've already done this, but you want to go to new branch and you go origin inside outside. Create that branch. I've already done it. I'm already on that branch. Now, well, you don't have to do this if you're just watching actually, but if you want to look at the code, you got to do this shit, which I recommend you don't do. Don't look at the code. Just watch the video and then try to do it yourself without copying. But anyways, I leave that to you. Now, let's take a look at what I have done, what I have wrought. So we'll view the history. The first thing you notice is there's a fuck ton of commits in this one. Pro tip, when you're working with source control, the more frequently you commit, the better. That being said, the way I'm using source control for these tutorials is in a non-orthodox manner. Normally the workflow would be quite different than what I'm doing. So don't just look at what I'm doing and think that's normal, because it's not. I am using it in a unorthodox way in order to facilitate tutorialization. Now, first change I made, change poly in out. Let's take a look at that. Poly closed, how did I change it? I added the facing coefficient, which is a floating point number. Plus 1 for inwards, minus 1 for outwards. And what you do is wherever in wherever in our algorithms we use the normal, we multiply it by the coefficient. And that'll allow the coefficient to control whether the normal points inwards or outwards, right? Negative coefficient is obviously going to reverse the thing. Normal, right? So normals normally point inward, but by changing the coefficient to -1, that will make all the normals point outward. So we use that here in the collision, and we also use it here in the strip extractation, because we want the strip when we're creating a wall, right, of a certain thickness, where's my fucking, there. When we're creating a wall of a certain thickness, we want that wall to be created in a direction opposite to the normal direction, right? Because if the normal is here, we're colliding here, so we want the thickness of the wall to go this way. Because if it was going this way, then the collision would look dumb because you would pass inside the wall. And that would be dumb, as I've already stated. Okay, so we did that shit, and then we go to map, and we change the constructor call in make unique. We change that to pass the coefficient. And I could just pass a -1 or a +1, but I created special static functions that return -1 or +1 just to make the code more self-documenting. It's very easy to see what we're doing here. We're creating an outward coefficient. We want... This seems wrong to me. This seems very wrong. I should want an inward coefficient, right? Because if this is the boundaries here, because I'm still working with only a single boundary, I should have made this inward, but it doesn't matter because we're moving on anyways. We're going to be loading inside and outside boundaries. This is all going to change. So forget about it. But I think I fucked it up. Anyways, maybe I didn't. Make outward coefficient returns what? Where is it? Outward returns a -1. Here, -1 is outward. I'm pretty sure outward facing should be +1. So I fucking fucked up naming this bullshit. Whatever. Doesn't matter. Moving on. Next thing is I implement loading both inner and outer. We got our innies and our outies. So how do we do that? Well, first things first, we add new members to store inner and outer, both the models and the boundaries. Now, how do we load inner and outer? Because it's going to take more than meets the eye. Up until now, what we've been doing is we've been hooking into the add... Well, fuck that. Learn how to write. Add vertex. The add vertex event. We've been hooking into this by overriding. And every time we get an add vertex, we just stuff a vertex into our container, which is a vector. And then at the end, we take that container and we empty it into a poly closed. And there you go, Bob's your uncle. Now we can't do that because we have two polycloseds and we need to differentiate between them. So how do we differentiate? Well, we're going to take advantage of a feature of DXF called layers. And the layer feature allows you to create as many named layers as you want. I guess there's a limit, but I don't know what it is. And what we'll do is we're going to create an inner layer and an outer layer. We put the outside boundary on the outer. We put the inside boundary on the inner. You put your right foot in. You take your right foot out. You put your right foot in and you shake it all about. Oh, my microphone just swiveled. That was weird. Oh, and my phone buzzed. Shit's popping off. Anyways, so how does this work in real life? Well, how this works is, first of all, for loading, let me explain how shit pops off when you get a polyline, when you're loading and a polyline comes up. So back to here, the event chain, as I understand it, is you get an add polyline, then you get a number of add vertex, dot, 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 and at the end you get an end entity. And that's how it works for a polyline. So up until now, we've ignored the add polyline, we've ignored the end entity, and we've only been interested in vertexes, or vertices. Because we've only had one polyline and no other vertex-based entities in our DXF file. Now, we're going to have multiple layers, and different layers are going to have polylines on them. Here is how I imagined, note the past tense, imagined the layer bullshit to work. I imagined there was going to be an add layer event, and then maybe like an end layer or something, and then another add layer. Wow, I didn't even try to write it out there. And then a bunch of bullshit, and so forth. So just like polylines are bracketed with, they just consist of add vertices bracketed by add polyline and end entity, I imagined add layer and something else would bracket all of the entities on a certain layer. So, keeping that idea in mind, this is how I fucked it up. So, basically I created an enumeration here, and this enumeration was for states. There are two states. One is the inner boundary state, which means we are working in the inner boundary layer, and one is the outer boundary state, meaning we are working in the outer boundary layer. And the other is just a null state, meaning whatever. I don't know. You done fucked up, maybe. And what we do is whenever we get an add layer event, we go, hey buddy, we'll check out that layer name, and if it's inner boundary, we set the current state to inner, and if it's outer boundary, we set it to outer. Obviously, I fucked up copy and pasting here, but don't worry about that. Pay no attention to the man behind the curtain. And Bob's your uncle. So, we use this to figure out what layer we're on, and then when we get an add polyline, we have another state variable that sets whether we are currently working on a polyline. So, add polyline sets that to true. And when we do that, we also size our container to the number of vertices that we are anticipating, because add polyline tells us how many vertices we can expect. So add polyline sets us to, hey, we're doing a polyline, and then add vertex does the same as it always does, pushes vertices into the container, and end entity is what closes the deal. The first thing we do is we check to make sure we're adding a polyline, because end entity could conceivably be called for other things, and we want to make sure we're handling end entity for a polyline. So we check whether we're working on a polyline. If so, first thing we do, we say we're stop working on that polyline. We check what layer we're on, and using that layer state information, we determine which data in the parent we are going to fill. Now note that previously, what we've been doing is the loader would fill up with vertex data, and then that data would be passed into a poly closed. Now what we're doing, fuck you. Now what we're doing is we're giving the loader a reference to the parent, and then the loader is accessing the parent's data members and filling them in. Because obviously it's going to be difficult to pass a whole bunch of different information. It's easier just to directly access the parent, just like we do with a drawable. So we use a parent pointer. We access the smart pointer here. We use the make unique to create bullshit, and we move the temporary vertex information from this vector into the constructor for the poly closed. There we go. So that is how it works, or in this case, how it doesn't work, but I'll get to that later. Just a couple of notes I made to myself here. First off, we don't do any error checking, and we probably should, but we don't. And we're not going to, because fuck that. That's not the focus of this tutorial. But in general, what you should be doing is you should be checking to make sure, you know, you actually load both layers and that you're not loading them twice and that you have a start position. Basically checking to make sure that the map file is all well-formed and kosher. But we just assume that everything is hunky-dory and we proceed. Next thing, here's just how I figured out, you know, I talked about this in the last tutorial. The way I figured this shit out was I just typed this pointer to and I took a look at IntelliSense and checked out what functions there were. And from those functions, I derived an assumption of how it works. As it turns out, that assumption was incorrect, but hell, I tried. Now, last thing I want to talk about, a little teachable moment here. When I created this add layer override, I did it by copying from add circle. I copied this, I pasted it here, I changed a couple of things. I changed add circle into add layer. However, I neglected to change circle data into layer data. So originally it was add layer DL underscore circle data. Now, if you do that, you will get a compile error because of this override qualifier here, which is optional, let me note. When you add override, you're saying, I want to override something in the parent class. And if your signature doesn't match a virtual function in the parent class, you will get a compile error. But if I had not put this override here, because remember, it's optional. It doesn't actually functionally affect anything about the code. If I had forgotten to put this or just said, hey, I don't need that shit, this would have compiled and it would have ran and it would have not have functioned the way I would anticipate it to. And I'd be like, why the fuck isn't it working? Why aren't you calling my fucking overrided function? And the reason why it isn't being called is because it's not overriding, it's actually creating a new virtual function because the signature was incorrect. So this little word here can save you a lot of pain in the dick if you just use it. But if you're like, I don't need that shit, I always code everything perfect, then you're gonna get fucked over one of these days. And just remember, when you do, Chili told you so. That concludes today's teachable moment. Let us continue. Wow, I'm making better time than I was in the last one. Doing things twice does pay off, but it's not what I want to do, because I'm a lazy bastard. Alright, so now map drawable in and out. So far, now we've loaded, or we assume that we've loaded the inner and the outer boundaries. We want to draw that shit. So let's go here. Pick that. Pick that. All right. So in the previous version, all we're doing is when we draw this shit, we just pass on a triangle strip drawable from outer model. The map doesn't actually do anything. It just is a pass-through to the drawing interface of a triangle strip. But that's going to change now. Why is it going to change? It's going to change because now we don't have a single triangle strip that we can just pass through. We've got two triangle strips. So what we're going to do is we're going to create our own drawable for map. That drawable is obviously going to have a reference to the parent. And in that drawable's rasterize, we're going to rasterize the drawables from the inner and the outer model. So we create them, we transform, clip them, and then we rasterize them both. Now, obviously, I forgot something here too. What did I forget? I forgot to actually return drawables, the map's drawable. So I'm still just passing through to the outer model drawable and ignoring the inner one altogether, which makes this all pointless. But yeah, we'll get to that. We will fix that in a later commit. Let us continue. Collision map in and out. So now we handle collision. This is very simple. Where there was 1, now there is 2. We just call handle collision for both the inner and the outer boundaries, and Bob's your uncle. Next. Fix copy and paste error. That would be this one here that I mentioned earlier. I realized that as I started to actually try to run the thing and find all the little typos and bugs that had accumulated. In this one, I just changed the name of the map file from map pause to map in out. And here is where I stopped the last tutorial because I fucked up. So what I want to do here is I actually want to fuck. No, I don't want to fuck. I mean, I do, just not right now. And probably not with any of you. But that's another story. Let's continue. I want to demonstrate why this system doesn't work. But in order to do so, I need to be able to reset the code to this position in the history. But I can only reset the code to wherever a branch is. And this is in the middle of a branch. This is in the commit. So I need a branch here, and I can do that. We can handle that shit. We're going to use git GUI because there's so many git commands. There's like a fuck ton. You will not learn them all. But they're all accessible through the command line. And I do not know anything about the git command line. I should learn about it, but I'm not going to. Because, fuck, it's too much work for me right now. I got things to do, man. Ain't nobody got time for that. So, there is an alternative to just using Visual Studio to access git commands, because Visual Studio only exposes a very small portion of git command and functionality. A larger portion can be accessed through git GUI. So that's what we're going to do. Or what I'm going to do. You can do it too if you want, or you can not do it. Either way. What you do is you would go open existing repository and you would browse to wherever your project's root folder is. I have already opened mine, so I just click down here in the list and open that shit up. And when we go repository, visualize all branch history, and we get a nice picture of all the shit. Okay, so what I want to do is I want to create a branch here. So I'll just go here. I will go create new branch. I will give it a nice meaningful name like butt plugs. Self-documenting. That's what we strive for. And then I will go check this branch out. Not as in like, hey, check that chick out, man. She's got some nice hooters. But as in like, set the code to this branch. And if we do that, we get a message, or we don't get a message. That's weird. Oh, because I don't have anything else open. Okay, that's fine. We don't get a message. Forget I even said anything. I'm going to go to solution. I didn't open the solution. So let's open the solution. And let's... well, there's a problem here. And the problem is, if I go here and I go open folder in File Explorer and I go to Engine, we will note that map in-out does not exist, which is a minor problem, but it can be rectified by creating it, and that's what we're going to do right now. For the purposes of debugging, we will create stuff. I'm losing my ability to speak. That is all right. It wasn't. I didn't have a great ability to speak in the first place, so no major loss. I want to create a new file. And we're going to create a very simple map. We'll use polyline. Create polyline. And we'll do this, 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 this. And let's get this in here so you guys can see. Snap on endpoints, this. So that's one polyline escape. Escape. And then I want to do, doesn't matter, create polyline from existing segments. What if I select this? Where's the selecting thing? I just want to select. Just let me select it. There we go. Whatever. I'm not gonna get into the difference between a closed and an open polyline and shit, because that is just fucked up. And we'll talk about that in a little bit. But I create the polyline here. This is gonna be the inside one. Now we'll create the outside boundary. And to do that, we'll go into polyline. We'll go offset. Choose the original polyline. That's this one. I did it right. I chose the original polyline. Why is it no entity found? Choose the first point. Okay, fuck you. Edit. No, select. Deselect all. No, stop rotating. Jesus Christ. I was talking to my microphone there. Okay. We want to offset. Choose this polyline. Why are you even? Oh, I did it. Holy shit. Okay, I think I know what's wrong now. I made it too small. The scale was a little off in my original polyline. That's a problem. Okay, well, you live and learn, right? Let's make a new polyline, shall we? What is the actual dimensions here? All right, so 800. Okay, this is a little more realistic. We're going to make it even a little smaller here. Okay, good. Now, polyline. Let's go back. Polyline. Polyline. This is wasting way too much time, polyline. We go endpoint. Snap on that. End this. End. We go polyline. Offset. That. There we go. Wow. Wow. What the fuck? This is one of the problems that I'm having with polylines, and that is that I can't find a good way of making a polyline closed, and even when I make it closed, it's still fucking... Oh, I fucking hate you, LibreCAD, but I don't really have a good alternative, so... And also you're free, so I guess I can't complain too hard. Create polyline from existing segments. Add a node, delete node. I mean, I can click on this motherfucker. But doesn't really matter, does it? See? Entity cannot be a closed polyline. So it's already closed. Doing this should make it closed, right? Then what we want to do is offset this motherfucker. Oh, wrong way. Why? Why did it go inside this time when outside last time? Tell me that. Let's try that again. Let's click here. Outside now. Okay. Now it's closed. So we have liftoff. Houston. The eagle has landed. Now, what I want is a circle. I'm going to put that circle here. I'm going to put it right here. That's a start point. Good. This track is a little small, but it'll work. All right. So now what we want to do is we want to give these, we want to put these motherfuckers on layers. We want to add some layers. What's the name of the layers? Layer names are inner boundary and outer boundary. So we're going to click on this one. This is taking way more time than I wanted it to. Inner boundary, we'll make it green. Good. Next one, outer boundary. We're gonna make that shit. No, fuck you. Outer boundary. I'm gonna make that shit magenta. Now, modify attributes U. Yes, I want to modify U. Continue. Layer is outer boundary. Fuck you, man. Not that it's important, but fuck you. When I said shit, I mean you take your color by layer, motherfucker. You. Layer, inner boundary, color by layer. Good. There we go. Now shit has officially popped off. We've got an inner boundary, outer boundary, circle. Good. Save this motherfucker. Save it as map in out.dxf. Now this should work. I mean, it shouldn't work because my code is fucked up, but it should work according to the theories of me of like 1 month ago. Yeah, that makes sense. Okay. So now we build, and we're gonna set some breakpoints here. Map. We're gonna set a breakpoint on all of these events, and we're gonna see what happens. So add circle, add vertex, add polyline, end entity, and add layer. So how does this shit pop off? Build. I did that already. Run. So the first event we get is an add layer event, which makes sense. We're thinking first you start a layer, then you give all the entities in that layer, then you start a new layer, give all the entities in that layer, and so forth. First layer is 0. That's the default layer. We don't care. Next layer, inner boundary. Okay, now we're getting into the shit. What event are we gonna get next? Now we get the outer boundary. What the fuck? So we were expecting inner boundary layer and then a polyline. We did not get that. We did not get that at all. So then we get add circle. Then we get add polyline. And after add polyline, we get a bunch of vertices. Then we get another add polyline, more vertices. Then we get bullshit, and then we get an error. Why do we get an error? Because according to our code, both polylines ended up going on the same layer, which was, I believe, the outer layer, the last layer to be added. So the outer layer got all the vertices, the inner layer got nothing, and then when we tried to use the inner layer, it was empty, and our program fucked up. Why is this thing not working the way we want it to? Because I had assumed that the loader worked in one way, and in fact, it worked in another way. And the way it works is this. You enumerate all the layers first, add layer, blah, 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 blah. And then you start adding your entities. So add polyline, add vertex, and entity. So if that's the case, how do you know which layer an entity exists on? That's the eternal question. That is the infinite jest. No, it is not. The answer to that question lies in the next thingamajig. That's a technical term, by the way. So what I'm going to do is I am going to change my branch from butt plugs to back to inside out. Cannot switch because there are uncommitted changes. Go to the changes, these files, delete. Yeah, fuck you. Delete that. go back to branches, change. Good. So we're back to inside, outside. Let's take a look at our history. So we go action. No, that's not it. We go changes, actions, view history. So we have butt plugs here. Using attributes for layer info. Let's take a look at what the fuck that means. First of all, you'll notice I deleted the fucking layer thing here. The state enumeration. But we'll get on to that later. So what we do is, in end entity, instead of checking to see what the current layer state is at, we use something called attributes. Now this exists in the parent class. It's a member. It's a data member. And it gives us a bunch of information about the attributes of the current entity being processed, being loaded. So with this, we don't have to memorize state information. The loader keeps a bunch of state information itself, which is very useful. So all we do is we check the attributes for the current entity that's being concluded. We make sure that the layer, or we check the layer of that, and we see if it matches one of the layers that we're interested in. And if it matches the inner boundary, we load into the inner. If it matches the outer, we load into the outer. Bada boom, bada bing. And that's about that. And because we are taking advantage of the state information in the loader, in the parent class, we don't need our own state here. So we can forget about that bullshit. And we can forget about add layer. We don't need to keep track of that. So we delete that. And what else? We don't need layer, state information. We still need adding polyline because we want to make sure that end entity is ending a polyline thing. So when we get an add polyline, we say, okay, we're working on a polyline, and then we hit end entity. We make sure that the end entity is for a polyline entity. So that doesn't change. But this state variable, disappears. Goes the way of the dinosaur. All right. So we move. When we end the polyline, we move the vertices into the constructor for the poly closed. And that empties the vertices for the next load. Or so the Germans would have us believe. So, next thing is a big problem I had. So what I had, the problem I had was, let's see if I can elucidate here. Let's go back to here. So what we do when we get an end entity for a polyline is we move all the vertices, meaning we empty the container in the loader, and we move those all into the container for the poly closed. Now this is important because if the container isn't empty, then those vertices will also be added to the next boundary. So if we load the inner boundary first, then when we're loading the outer boundary, all the inner boundary vertices would still be in there. If we just use the copy constructor, that would be bad. We want to empty the container so that it's clear for the next load. However, it actually doesn't work that way. The way the code is right now, that won't happen. And that actually surprised me. So even though this constructor takes an R value reference. You would think if you passed an R value reference into the constructor for this container, it would move the vertices from this R value referenced container into the current container. However, it doesn't move them, it copies them. Now I'm thinking, what the fuck? I specifically listed this as an R value reference so that you would move that shit, and you didn't move that shit. Now, the way it works is if you have a named variable, even if that named variable is an R value reference, it will not use the R value reference version of a function. If there's an overload, it will use the normal reference version. So even though this is R value reference, you still have to put move in here as well in order to get that one to move the shit out of the first container into the second one. You gotta call std move on that shit twice. Now std move doesn't actually add any overhead or anything. You don't have to worry about that shit. It's just a little annoying. There's reason, I've read about reasons why this is the case, but I'm not convinced. I think it's just bullshit. But it's the bullshit we got to work with. So you add that move in there and then it empties the container as we would want it to. Wow. That took a while to explain, but wasn't necessary. Now here's where I realized that I was returning triangle strip drawable for the outer only when I wanted to return the drawable for the map. So I fixed that bullshit. Thank you very much. And then here was a very minor change, but it made managing resources better. I added a new filter to the project file, and I put all the media in that filter. So I put the image in here. Well, that's cool. It even gives you a little preview of images. I didn't notice that before. Anyways, so I added this shit in here so that it would be tracked better in the source control. The changes would show up better. And no real change, no substantial change, substantive change, just better organization. Now here is where shit started to pop off. What I'm going to do is I'm going to add another branch here, an add media folder. So I expected everything to work once I got to this branch here. I figure everything's good now. This shit's going to work. I'm confident. I want to create a new branch. I'm going to call it Wizard Sleeves. I could have called it Meat Curtains, but I'm classy. I'm too classy for that shit. So Wizard Sleeves, and yes, shit changed, so we want to reload that shit. What changed exactly? Not much. I've already talked about it. Let's get rid of these breakpoints. And let's run this motherfucker. So we're going to go release. Because I'm confident this will work. Oh, yes, sir. All right, so we got our shit. And we move, and we see, oh, shit. Yeah, we got inside boundary. We got outside boundary. And we move up here. And holy mother of Jesus, what the fuck is going on? So, what the fuck went on? Something is wrong. So I debugged it a bunch and I figured it out. I'm going to save you guys me debugging, showing you me debugging it, and just show you what the fucking problem is. The problem is LibreCAD. Okay, so you got a closed polyline. We'll give the simplest polyline you can have, a triangle. You got your vertices A, B, and C. So an open polyline would have, let's say, an almost closed triangle would have vertices like these. A, B, C, D. But a closed one only needs 3 vertices. This is what my program expects. What fucking LibreCAD gives you is this. You get a one like this, but it's got A, B, C, D. So you get 4 vertices for example, a triangle. And A and D they have the exact same coordinates, but you've got 2 vertices stacked on top of each other. And the loader does not like that case. It doesn't expect it for a polyline. Try calculating the normal for this. Calculating the normal requires taking the distance, and the distance is 0. You divide by 0, you get infinity. You get a big fucking white screen of death. And that's not good. And I can't figure out how to make LibreCAD consistently output this kind of closed polyline. I don't know. I fucking don't know. And I can't be fucking asked to try to figure out how to make this fucking program work the way I want it to. So what I decided to do is create a workaround. We're going to pre-process all of our polylines. And what we're going to do is we're going to check to see, we're going to check, for example, let's take a look at vertex B. We check to see if A or if C is exactly the same coordinate as B. So if 2 adjacent vertices have the same coordinates, we delete one of them. And what that will do is, in the case of, you know, A/D, B, C, that'll delete, for example, D, so we just get ABC, which is what we want. So we're going to delete duplicate vertices. That's the plan. Where's my shit? Where's my dogs at? So what we do is we fucking... Where's my... No. Here. Shit. We go here, we go changes, we go actions, we go view history. Here we go. We don't want wizard sleeves. We want to change our branch inside outside. And get rid of that. So go back here. There's probably better ways to access this stuff, but I don't know them. Okay, so remove duplicates. That's what we're doing. Removing duplicate fucking bullshit. So I create a function, just like we created a function is clockwise winding and make clockwise in order to pre-process the polylines so that they all wind in the same direction. We're also going to pre-process them to remove duplicates. So what we do is we... where's my shit? Where's me? Where is it? There we go. So what we do is... I don't know why it's highlighting just this stuff. What did I change here? Is clockwise winding. I deleted this and I deleted this because it wasn't necessary. Just some housekeeping. Anyways. So adding new function, remove duplicates. We're going to iterate. We're using iterators here. We're going to iterate through the container from the beginning to the vertex before the very end. Right? Because what we're doing is we're comparing every vertex to the vertex that comes after it. So in the case of, let's see, in the case, we're gonna make something like this. A/E, B, C, D. We compare A to B, B to C, C to D, D to E. Wait. Yeah. So we do that. We compare A to B, B to C, C to D, D to E in the loop, And then at the very end of the loop, we compare the very last element to the very first element. That's a special case, right? Because we're looping around. So, in the loop, we want to go from A to D. We don't want the iterator to point to E, because that one is going to be handled as a special case at the end. So what we do is we go from the beginning to one before the end. So we get vertices.end, and then we use std previous to get the one before that. And we make sure we loop until I is not at the end, which is one before the actual end. Confusing. And while we're doing that, we increment. And so what we do is we compare current one to the next one, the one after the current. And if they are the same, we erase the current one. Now, calling erase, what that does is when you erase an element in a container, that invalidates the iterators. So what we can do is, instead of having to restart the process all over from the beginning, we can update I with the return value from erase. And what erase returns is it returns the, I believe it returns an iterator that points to the element that follows the element that was erased. Right? So, for example, that's not what I wanted. Yeah. Let's say we had something like this. A, B / C, D. Like this. So first thing, I points to A. Compare A to B, different. Iterate. I points to B. Compare B to C. They're the same. Delete B, and the return value for that would be the next one, which is C. So now I will point to C. That's what's going on. And then we just continue on like that. And then at the end, we compare the very last element to the very first element. And if they're the same, we remove the very last element, which is just can be removed with pop back. All right, so that's very simple. And then, of course, we call remove duplicates in all of the constructors. And Bob's your uncle. Except, of course, that doesn't fucking work. And the reason it doesn't work is, first of all, when we erased an element, that invalidated the iterator I, but it also invalidated the iterator end. So we would have to update the end. So we update it here. We say end is equal to the element before the last element. So now we update I and end whenever we delete or whenever we erase an element. How is that? Well, still not good enough, I guess. Now, the reason why that wasn't good enough is fucking complicated. But I guess I should explain it. Because working with iterators, and especially working with containers and iterating through them and deleting shit while you're iterating, is fucking, it's a dangerous preoccupation. So if you're gonna do it, you shouldn't do it, but if you're going to do it, you should make sure you're careful, which I didn't. So why is this bad? Well, there's going to be cases where you get fucked up. Let me think of one. I can't think of it right off the top of my head, but I can probably work it out. So let's say you've got you got A, B, C, D / E. So you've got two vertices here. You iterate, you iterate, you iterate. You get to D. You check D is equal to E. They are equal. You delete D. I now points to E, which is the next one. End, let's look in here. End points to the one before vertices.end. Now vertices.end doesn't give you the last element. It gives you, for every container, iteration works like this. A, B, C, D, E, and then end, which is an invalid iterator that signals the end of the container. All right. So when we make our end iterator point to vertices.end previous, end is going to point to E, which is what I is pointing to. So now end and I both point to E. So far, so good. Now we finish this thing here. We go back up here. We increment I. So now I isn't pointing to E. I is pointing to this end, which is different from the end iterator that we're using. This is a position, the end position, which is past the end of the container, past the last valid element in the container. I should have used a different name for that end iterator, but I always use end. Anyways, so now I is pointing to the past the last element position. End is pointing to E, which is the very last element. And in doing so, we check our condition, is I not equal to end? Yes, it is. And we keep iterating. So now we try to make comparisons. But remember, I is pointing to an invalid position. That's not an element. That is a position indicating you're done. So you get a breakpoint happening. You get an error. You get shit, explode. So that is why this doesn't work. Complicated, but not super complicated, I hope. If that was just too complicated for you, then you need to maybe study up a little bit more about the way iterators work and looping through a container with an iterator. But anyways, so this doesn't work. Long story short, this does not work. Fixed loop iterator bug. Wait, which one did I do? This one. All right. So how did I fix that? I fixed it by making this iterator increment only if we didn't delete an element. So if we delete an element, I automatically moves to the next thing, right? Because the thing that I was pointing to gets erased. I will now point to the thing after that thing. So we don't want to increment it again. We want to just use it the way it is. So in cases where we delete something, we don't increment I. Otherwise, we do increment I. So there is my solution to that problem. It's not my favorite solution because I like to put the incrementer right here because that's what that position is for in a for loop. I'm just making this point empty. I like to use this if I can, but in this case, no dice. So I do it this way. Now here it says fix dumb bug, remove duplicates. So there must have been some dumb bug. Oh, okay. Right. So here is a dumb bug. I try to compare vertices.end with vertices.beginning. But like I said earlier, end is not the actual last element. It is the point after the last element. So if you try to dereference that and get the element, the program will puke. So that was a dumb bug. So instead of getting a iterator to the first and last elements and then dereferencing the iterator and comparing, I just call functions that get the first and last element directly without using iterators back and front and compare them. That's a much nicer solution. And again, if the first and the last element are equal, delete the last one. All right, so this should fix the problem. And it does fix the problem, but there's another problem. And this problem is again because of fucking LibreCAD. Fucking, ooh, I hate you, LibreCAD. If you weren't free, we would be so done. So what's the problem with LibreCAD? Well, remember how I created the track that we used previously? I created the track by creating a polyline and then offsetting that polyline with another polyline. Just using offset to create another polyline. And that's a nice, easy way to create a track. So what LibreCAD does in its infinite wisdom is, let's say we've got our fucked up bullshit polyline, which has two vertices on top of each other. Now A and D are the same value. Let's say that this is the origin. So they're both equal to 0, 0. Those are the coordinates for A and D. So what happens when we do the offset? So this would be W, X, Y, and Z, right? Now we would expect W to be the same as Z, but actually it's not the same as Z. It's like a little fucking different. So if W is going to be 2, 2, because of the way offset works, Z is sometimes like 2 and 1.99967 or something like that. Some bullshit like that. Just a little bit different. Not always. Sometimes it's 2, 2 and 2, 2. But sometimes it's 2, 2 and 2, 1.9999673 1337. Fuck you, programmer. I'm gonna wreck your day. So, fucking LibreCAD. How do we solve this problem? Will you do another workaround? Basically, my solution is fuck that. Fuck that. Yes. In our algorithm where we compare a vertex to its next vertex, we don't check to see if, for example, Z is equal to Y. We check to see if the distance between Z and Y is less than some threshold. So if points are very close to each other, we consider them to be the same, have the same coordinate, and we delete one of them. So we're adding a little tolerance. They don't have to be exactly the same. They just have to be close enough. And if they're too close, and we can feel a little poke coming through, you got to step back. What I'm trying to say is we delete one of them. So what the fuck, barbecue, LibreCAD, what does this one do? Here I just created some kind of test, and the test fucked up because of, you know, the stuff I just explained. So my solution is fuse close vertices. So all vertices that are close to within a certain threshold of tolerance, the fuse threshold, which I set to be 0.01 units, they are considered to be the same, and one of them is deleted, essentially fusing them together into one vertex. And how that is done is, instead of just doing an equals, we subtract one from the other, we get the length of that vertex, or of that vector, and we check to see if it's less than the fuse threshold. And the same thing down here. subtract the two vertices to get a vector, because vertices are vectors, right? Subtract them to get a vector from one to the other. Check the length of that to find the distance between the two vertices. And if it's less than the threshold, we gotta talk. You and me, we gots to talk. All right. So what's this one do? Here I just remove. Oh, this is a conversion operator that we use to pass the loader. When we pass the loader to the constructor for the poly closed, it would convert the loader into our value reference to the container so that we could move the vertices out from the loader into the poly closed. But we don't use this anymore. Now our loader directly accesses these members of the parent, the map. So we don't need this anymore. So I delete that motherfucker. And here I just clean up all the notes that I made to myself. So I clean up all this shit. And yeah. I think I talked about all these notes now. Yep. Talked about that one. Talked about this one. Sort of talked about container algorithms. Like I said, this std previous or next. There's also one called std next. And there's a whole bunch of algorithms that you can use to work with containers and iterators to do a whole bunch of crazy bullshit. Like, for example, std reverse will allow you to reverse a container, which I use in make clockwise, etc. These things exist. Yeah, I talked about that, talked about that, did not talk about this. Talk about const member, memory space, const expression. Okay. So adding this as a constant memory to the class means that every time I create an object of this class type, it's gonna store this value in memory. Even though it's a constant, doesn't change, it's still gonna store it in memory, which is kind of a waste. Now you could get around that by using, for example, #define, using a macro, but I don't like macros because they're not as safe as using actual compiler shit. Pre-compiler, not as good as compiler. But the real solution that I would like, making this a static variable, if you make it static, then there's only one, and it goes for every class, every object in the class. They will all share just one memory space, which is all you need. But you're not allowed to make static constant float. That's not allowed. The reason is bullshit, but that's another story. The solution is const expression. Const expression is fucking sweet, and it's C++. What's it called? C++ 13 or something. I forget what it's called. But it's in the new C++ standard. But it's not implemented yet in the Microsoft shit. Not fully implemented. And when it is fully implemented, you'll be able to use const expression to dictate things that are done at compile time. Things that are calculated at compile time. And basically, it's going to save on that little bit of memory that you lose when you put a constant in the class like this. And a whole bunch of other bullshit, but I'm not going to explain it because it's not even a thing yet in Visual Studio. If you're interested, look it up because it's cool. But just to let you know that this wastes a little bit of space. So it's not a big deal because there's only one map object for the game. But if it was like a bullet object and there was like, at any given time, like 5,000 bullets, it would add up a little bit. You might be thinking about using a define or something else instead in that case. But anyways, yeah. So this commit just cleans everything up, and that's it. It's all done. So I can switch to this branch. Go to branches. Inside, I'm already on that branch. Build it. Run that motherfucker. Oh yeah, I created a different map here. It's more like a track. So I can run this motherfucker. And yeah, it works fine. Look at that. It is the world's most boring racetrack, but it's still fucking amazing because it works. And when something that you made works, it's like the fucking tits, man. Everyone else looks at it and saying, well, whatever, dude, that's not that impressive. But I'm like, fucking fuck you, man. This took me way longer than I am willing to admit. But anyways. So that's what we did. That's what I did. When you're done, you can go into here. And, oh, this isn't updated. Let's go, wait, update. Yeah, so now it reflects that we're checking out this branch. And I'll remove this branch and I'll remove this branch because we're not using those anymore. And there we go. Shit has popped off. That's the map system so far. No, I don't want this. Yes. Okay. So next lesson, because this one's done. It's not really a lesson, it's just an episode. There's a distinction. Next episode, we're going to add a functionality for the shield. We're going to make it so that the shield has a meter. The meter is displayed on the screen, so we're going to add a user interface element, our first user interface element. And we're going to make it so that when we bounce into the walls, the shield meter depletes by some amount. So that should be simple, which is what I said when I was doing this one. I said, well, this add an inside and an outside, that'll be simple. Fuck no, man, that was fucking hard. Anyways, so that's for next time. Now I'm done, and my voice is also kind of done. And I will see you guys later. Oh, and yeah, don't forget, one thing, always remember, if you like the video, consider clicking the like button. It helps a lot, makes me happy. It increases the probability that I will have the motivation to create another episode at an earlier junction. Consider that, and I will see you later.